Imagine standing at the threshold of an open airlock. Before you lies not a familiar horizon, but a foreign, terrifyingly hostile world. What would you feel if you took a step outside, without a spacesuit? In just a few seconds, your body would become an arena for the most extreme physical processes in the universe. Your blood would boil in your veins at room temperature, or you'd be crushed into a flat pancake by atmospheric weight, faster than your brain could register the pain. Today, we embark on the darkest journey through the solar system. We will live out the finale on every planet, from the scorching furnaces of Mercury to the icy oblivion of Neptune. I will tell you in detail exactly how human organic matter breaks down under pressure and radiation. Stay tuned until the end, because the most sophisticated and gruesome death awaits you in a place you'd least expect. Let's set the rules for this hypothetical execution. We're tossing out Hollywood sci-fi and sticking to cold, ruthless physics. Our subject is an ordinary person in a t-shirt and jeans, without an oxygen tank or protective composites. Each planet is a unique set of parameters. Temperatures that melt lead, pressures that crush granite, and a toxic chemical cocktail instead of air. Astrophysicists and biologists have long calculated exactly what would happen to soft tissues, mucous membranes, and bones in these conditions. This isn't just an instant flash. It's a process full of terrifying nuances. We'll break down every scenario to understand just how thin the line is that separates our life from total molecular decay. Let's start at the beginning. The place we call home. Earth is a statistical miracle and an incredible anomaly. We are so used to the pressure of one atmosphere holding our internal organs and fluids in place that we simply don't notice it. Our cocktail of nitrogen and oxygen is perfectly balanced for our lungs. Here, death is a biological process: old age, cardiac arrest, or an accident. But the moment you leave this thin protective blanket, physics turns into a merciless executioner. On Earth, you have minutes, hours, or even days to fight for your life. On any other planet, the clock ticks in seconds. Remember this feeling of comfort, the weight of the air you don't feel, and the soft sunlight. You won't find that again. Ahead lies only absolute, chemically pure hostility, which means no protection. If you end up on the day side, you face direct contact with heat reaching plus 430 degrees Celsius. But you won't even have time to roast. Due to the lack of external pressure, oxygen will literally start tearing out of your blood through your pores. Your tissues will begin to bloat like in a vacuum chamber, and the capillaries in your eyes will burst instantly. If you land on the night side, minus 180 degrees Celsius, you'll turn into an ice statue faster than you can finish an exhale. It's a death of extreme contrast. The solar wind sears your retina while your feet freeze solid to the icy regolith. If Mercury is an empty oven, Venus is hell under a hydraulic press. The temperature stays steady at plus 470 degrees Celsius, but the main problem is the air density. Surface pressure is 92 times higher than Earth's. Imagine the weight of an adult elephant pressing down on every square centimeter of your body. It's like diving 1 kilometer deep into the ocean. But instead of water, you're surrounded by superheated carbon dioxide. The second you step outside, your lungs will collapse, your bones will turn to mush, and thick clouds of sulfuric acid will begin melting your remains into toxic sludge. You won't even feel the heat. The pressure will destroy your nervous system in a fraction of a second. Mars is often called a second home, but for a human without a suit, It's an elaborate trap. The main enemy here isn't the cold, but the low pressure less than 1% of Earth's. This is well below the Armstrong limit. What does that mean? As soon as you try to inhale, the boiling point of your body's fluids drops below 36.6 degrees Celsius. The saliva on your tongue, your tear fluid, and most terrifyingly, the moisture in your lungs' alveoli will begin to boil. This isn't heat. It's the physics of liquid turning to gas at low pressure. You will bloat, feeling the steam rip you from the inside, while desperately trying to gasp for thin carbon dioxide. Add to this the piercing frost and dust that bites into your mucous membranes. Death from hypoxia will occur in 1 to 2 minutes, but they will be the longest 2 minutes in the history of your consciousness. Forget about solid ground. On gas giants, there is simply nowhere to step. Jupiter. Your journey begins with a fall through endless layers of ammonia clouds. At first, you'll be in free fall, surrounded by icy fog. But as you sink, the pressure rises exponentially. The atmosphere will become so dense that eventually the gas density will match your body's density. You'll simply get stuck in that layer, like a fly in thick amber. Here, the temperature rises to thousands of degrees. You won't just be crushed, you'll be turned into plasma, eventually becoming part of an ocean of liquid metallic hydrogen. Saturn. The scenario is similar, but with one chilling difference. Saturn is the planet of the fastest winds, reaching 1,800 kilometers per hour. You won't just be compressed by pressure, you'll be torn apart by monstrous vortices while still in the upper atmosphere. It's a death like a dark, endless nightmare, falling into an abyss where light vanishes forever and gravity squeezes every atom until you become invisible dust. Welcome to the realm of the ice giants. Here, eternal permafrost and extreme temperatures around minus 220 degrees Celsius reign. On Uranus and Neptune, you face instant vitrification of soft tissues. The neurons in your brain will stop transmitting impulses almost instantly. You won't even have time to feel the cold as pain. If Jupiter cooks you with density, here you are, first turned into a super fragile crystal. Then, Neptune's supersonic storms take over. They pick up your frozen body and literally grind it into powder against particles of methane ice. This is the fastest disintegration. You become a cloud of icy dust in seconds. The climax of our parade of deaths. Here, you don't even need to get close to the surface. Millions of kilometers before reaching the photosphere, powerful radiation will begin destroying your DNA at a subatomic level. As you approach the sun's corona, your body won't just burn, it will transition directly into a state of plasma, bypassing the burning stage. The atoms that make you will be stripped from their orbits by the solar wind. This is the fastest and cleanest death in the universe. You become light and heat in a mere microsecond. No pain, just an instant flash, and the transformation of matter into pure energy. This journey isn't just a collection of horror stories for YouTube. It's the only way to truly realize how unique and protected our planet is. Space isn't just empty space. It's an active environment that tries to disassemble us into atoms every single second. We are biological beings adapted to an incredibly narrow, almost surgical range of conditions. The fragility of human life on a solar system scale is staggering. That is why every new spacesuit model and every rover launch isn't a whim of billionaires, but a desperate attempt by our species to learn how to survive outside our terrestrial greenhouse. We are sparks of life in a cold, dark ocean. And our task is to keep those sparks from going out. We've looked at all the ways it could end. Which planet seemed the most terrifying to you? Personally, Mars chills me to the bone, that illusion of being able to survive while your blood begins to boil. Write your pick for the worst planet for a stroll in the comments. If you enjoyed this deep dive, hit the like button and subscribe. It's the best way to support the channel. Next time, we'll analyze something even more insane. What would a person feel falling into the event horizon of a black hole? Trust me, the laws of physics break down so hard there that death will seem like the easy way out. See